a fast method for finding the nth term of a sequence. Although sequence notation is more suitable to represent the terms of a number sequence compared to the list method described earlier, we are not fully satisfied, as still, we have to calculate the terms one by one to get to the desired term. In some sequences, however, it is possible to identify formulas that allow us to calculate the nth term of a sequence, x, n, based on the first term x1 without using the long, recurrent procedure described earlier. Let's explain how to find the nth term in two widespread sequences, arithmetic and geometric. 1. Finding the nth term in an arithmetic sequence. Earlier in this tutorial, we have explained that in an arithmetic sequence the difference d between two consecutive terms is always constant. Thus, denoting the first term of such a sequence by x1 and the general term by xn, we have the following shown on screen. Hence, after n recurring operations, we obtain the general term x, n of an arithmetic sequence in terms of the difference d and the first term x1, we have the following shown on screen. Thus, if for example, we have the first term of an arithmetic sequence x1 equals -9 and the common difference d equals 7 given, we can effortlessly calculate whatever term of this sequence we want, no matter how far from the first term in the list it is. For example, the 108th term of this sequence, n equals 108, we have the following shown on screen. If you have doubts, try to solve the exercise by the recurring method J. Example 1. The fourth term of an arithmetic sequence is 17 and the ninth term of the same sequence is 32. A. Find the first term of this sequence. B. Find the 86th term of the same sequence. Solution 1. A. First, let's calculate the common difference d. We have x4 is equal to 17 and x9 is equal to 32. We get from x4 to x9 by adding 5 times the common difference, as the ninth term is 5 terms away from the fourth one. Hence, we have the following shown on screen. Now, we can find the first term, x1, by using the same procedure. Since x4 is 3 terms away from x1, we have the following shown on screen. As for the 86th term of the sequence, n equals 86, we have the following shown on screen. It is also possible to find the nth term of arithmetic sequences in cases similar to the above by solving a system of linear equations. For some people, this method may seem more suitable. Thus, since we have the following shown on screen. We have the following shown on screen. We have the following shown on screen. Solving the system of linear equations obtained yields, we have the following shown on screen. Multiplying the first equation by -1 to eliminate x1 yields, we have the following shown on screen. Hence, we have the following shown on screen. The rest of the solution used for finding x86 is the same as in the previous solution. 2. Finding the nth term in a geometric sequence. We can use the same approach in identifying a general formula for finding the nth term of a geometric sequence, xn, when the first term x1 and the common ratio r are given. Thus, we have the following shown on screen. We obtain the formula for the general term xn of a geometric sequence, we have the following shown on screen. For example, if the first term of a geometric sequence is 3, x1 is equal to 3, and the common ratio is 2, r equals 2, then the 12th term, x12, of this sequence, n equals 12, we have the following shown on screen. Example 2. The first term of a geometric sequence is 81 and the common ratio is 1/3. Calculate the eighth term of this sequence. Solution 2. We have x, 1 is equal to 81, r equals 1/3 and n equals 8. Thus, given the formula for the general term of a geometric sequence, we have the following shown on screen. We obtain for the eighth term of this sequence, we have the following shown on screen. 3. Finding the nth term of combined sequences. When a sequence is a combination of two or more types of sequences described, the general term is calculated by considering each component sequence separately. For example, in the sequence, we have the following shown on screen. There is a combination of an arithmetic sequence, in the numerator, and a geometric one, in the denominator. Therefore the nth term of this combined sequence is calculated in two steps, one for the numerator and the other for the denominator. For example, if we want to find the 14th term of this sequence, the 14th numerator equals x, 14, where x, 1 is equal to 1, d equals 2 and n equals 14. Thus, we have the following shown on screen. The 14th denominator equals y, 14, where y, 1 is equal to 2, r, equals 2 and n equals 14. Thus, we have the following shown on screen. Therefore, the 14th term, t14, of the given sequence, we have the following shown on screen. Example 3. Calculate the 11th term of the number sequence, we have the following shown on screen. Solution 3. The numerators form an arithmetic sequence where the first term is x, 1 is equal to 4 and the common difference is d, equals -3, while the denominators form a geometric sequence where the first term is y, 1 is equal to 128 and the common ratio is r equals 1/4. Hence, the 11th term in each sequence, n, equals 11, we have the following shown on screen. We have the following shown on screen. Therefore, we have for the 11th term t, 11 of the original fractional sequence, we have the following shown on screen. 4. Finding the nth term of quadratic sequences. As we explained earlier, in quadratic sequences the difference between two consecutive terms changes by the same amount each time when moving from left to right. Therefore, it is important to find this change of differences, i.e. the second difference, as it is constant and can be processed easier. Since such sequences are called quadratic, they must have many things in common with quadratic equations. In fact, we saw earlier in this tutorial that terms change from each other in a quadratic polynomial fashion. Indeed, the nth term of a quadratic sequence is of the type, we have the following shown on screen. Where a, b, and c are constants, a, not equal to 0, while n represents the number of the term giving that the difference between consecutive terms is not constant and therefore, we cannot rely on the common difference d anymore. There is a standard procedure used to find the nth term of a quadratic sequence, explained. Step 1. Find the constant second difference of the given quadratic sequence. Step 2. Divide that number by 2 to obtain the coefficient a. Step 3. Subtract the term a, n, squared from each known term of the quadratic expression a, n, squared plus b, n plus c. The remaining expression is therefore linear. Step 4. Calculate the nth term of this linear sequence. This gives b, n, plus c. Step 5. Substitute all values found in the original quadratic expression. For example, in the quadratic sequence 6, 13, 26, 45. The difference between consecutive terms increases by 6 every time we shift from left to right, we have the following shown on screen. And so on. Therefore, the coefficient a, in the quadratic expression a, n squared plus b, n plus c is, we have the following shown on screen. Hence, the value of a, n squared for the four known terms of the original quadratic sequence, i.e. for n equals 1, 2, 3 and 4, is for n equals 1, the value of 3, n squared is 3, n. 1 squared equals 312 is equal to 3 1 is equal to 3. For n equals 2, the value of 3, n squared is 3, n. 2 squared equals 322 is equal to 3 4 is equal to 12. For n equals 3, the value of 3, n squared is 3, n. 3 squared equals 332 is equal to 3 9 is equal to 27. For n equals 4, the value of 3, n squared is 3, n. 4 squared equals 342 is equal to 316 is equal to 48. Therefore, the difference between the original term and the corresponding a, n squared terms obtained, which gives the first four terms of the new linear sequence, we have the following shown on screen. In this way, we obtain the linear sequence 3, 1, minus 1, minus 3, where the first term is t. 1 is equal to 3 and the common difference is d, equals minus 2. Hence, the general expression for the nth term in this new arithmetic sequence, we have the following shown on screen. This is the b, n plus c, part in the original quadratic sequence expressed in terms of n. Hence, we have the following shown on screen. This expression allows us to calculate whichever term of the original quadratic sequence we want. For example, the 24th term of this sequence, n equals 24, we have the following shown on screen. Example 4. Find the 34th term of the sequence, we have the following shown on screen. Solution 4. Carefully look at the difference between two consecutive terms. First, it decreases by 2, then it remains constant, then increases by 2, by 4, by 6 and so on. Therefore, the change in difference increases by 2 every time we move from left to right. This means we are dealing with a quadratic sequence, where the general term has the form as the following shown on screen. Hence, since the coefficient a is half of the change in the differences, i.e. a equals 2 over 2 is equal to 1. For convenience, we can create a table where all the necessary information as explained in theory is included. We have the following shown on screen. In this way, we obtain the linear, arithmetic, sequence, we have the following shown on screen. Where the first term t, 1 equals minus 9 and the common difference d equals minus 5. Hence, we obtain the general term t, n of this arithmetic sequence, which gives the b, n plus c, part of the quadratic sequence. When expressed in terms of n, we have the following shown on screen. Therefore, the quadratic general term x, n is shown in the following on screen. Now, we are ready to find the 34th term of the original sequence, n equals 34. Thus, we have the following shown on screen. That is all for lesson 12.1.4, and the end of tutorial 12.1. To continue this chapter, please watch 12.2, Introduction to Working with Arithmetic and Geometric Series. How to find the sum of the first n terms of a series. Thank you for watching. Make sure to like and subscribe to keep up to date with new videos. For more information, calculators, and tutorials, please visit www.icalculator.info.